So the next part that we are going to see is, the next mathematical part is vector algebra, right? It's called as vector algebra. Meaning we are going to learn about what are vectors and try to understand what are the different kinds of mathematical operations we can perform between them, right? So basically, before you understand this vector algebra, right? See, vector algebra actually falls under the mathematical part, right? And which is also important for the physics. Where we use the concept of vectors is for something called as physical quantities. So what do you mean by physical quantities? So what do you mean by physical quantities? The measurable quantities. As the name suggests, no, quantity is something that can be measured. Physical refers to physics quantities. So if you are able to refer to those values or refer to those quantities, they can be majorly classified into two segments. You can either call them as a scalar or something called as vector. Okay. So here, first we need to understand certain terms before we get into the mathematical operation. For that, the first thing that I am going to define is a scalar quantity. So what do you mean by a scalar quantity? Any physical quantity, that has magnitude but no direction is said to be a scalar quantity. A physical quantity that has magnitude but no direction is said to be a scalar quantity. So what are going to be the examples of this? The examples of this are distance, speed, displacement is a vector quantity, time, mass, temperature, right? All these are examples of scalar physical quantities. So, you're able to understand? Right. This is easy, right? Now, the next question is about its counterpart, which is called as a vector quantity. So, let's understand what are vectors. So, what are vectors basically? They are also physical quantities which have both magnitude and direction, right? So if you write it only till here, you're only half correct. An important point that needs to be added here is they should obey the vector laws of addition. So if a physical quantity has only magnitude and direction, you cannot call it as a vector. One best example for it is electric current. Electric current has magnitude, it has direction, it always flows from higher to lower potential. But if you ask, is it a scalar or a vector quantity? It is not a vector quantity. It is scalar because it does not obey the vector laws of addition. Similarly, when you take time, time has magnitude and direction. It is always forward direction. Time cannot be calculated in the reverse. It is not a vector quantity. So they should follow vector laws of addition. Am I clear with this? So the example for this is displacement, velocity, acceleration, momentum. So when I say momentum, both linear and angular get covered under it. Then you talk about force, then you talk about torque, etc. So these are all the examples of vector quantities. Am I clear with this? It's not about school, duh. It's not about school. It's about the concept. Understand it. This is important, okay? If at all they have forgotten, make a note of this. They have not mentioned, now you know it. Okay, now concentrate. Am I clear with this? Okay. Now our complete focus is going to be only on vectors.